Next example, we'll look at the first sort of modern machine gun. The Maxim gun that came out in the late 1880s used a belt feed mechanism and could fire up to 450 rounds per minute. Notice in this antique that the barrel is cooled by a water jacket. The Vickers machine gun replaced the Maxim by World War I, and the Vickers was an improvement on the Maxim design. These are fully like squeeze the trigger and it just keeps firing using gas from the recoil. So we look at the design of a Vickers machine gun. There's 4 1/3 liters of water in this cooling jacket, and the water could come to a boil and the steam would go here to be condensed. So let's take a look at what we can calculate for this Vickers when it was firing and one of the problems. So we've got about a 450 rounds per minute with 4.3 liters of cooling water. Research the cartridge and you get the Mark 7 used a 174 grain bullet. That translates to about 11.28 grams. And it had a muzzle velocity of 744 meters per second. When we look at this, we can plug in this number and get the energy in the bullet according to the factors was 3,121 joules in a bullet. On the previous slide, we saw that only about 30% of a bullet's energy goes into kinetic. So this factor here is only 30% of the actual energy of the gunpowder. This would allow us to scale back to 100%. We're not interested in that. We only want to know how much heat was in there. Well, when we look at the energy pathways for the gun, again, it's very similar to a car. About 30% heats the barrel, and about 30% is kinetic. So this 3,121 joules of kinetic energy is going to be very close to the same for the thermal heat. So we've already got our answer. We can save ourselves a lot of effort to go back to the total and then downgrade to 30%. You're going to get the same number. So when we fire 450 rounds in a single minute, this gives us 1.4 million joules of thermal energy will enter the water. Now, how hot's that water going to get if it starts at 10 degrees? Well, 1 gram of water is 1 milliliter. So 4.3 liters is 4.3 kilograms. Water has a heat capacity of 4128 joules per kilogram per degree C. We'll go to 4200 since this is the technique, not the actual answer. Knowing that Q is going to be 3,121 joules, we know the mass of the water, we can solve for delta T. The water would have gotten 77 degrees cooler or hotter, making it 87 degrees in a single minute of full-on firing with the gun. So it's easy to see that, yes, in fact, the stories of the water boiling in those jackets, absolutely true, that the water could come to a boil. What happens once it reaches to a boil? We switch equations again, so we won't do that part. I'm trying to confine our water behavior between 1 and 99 so we don't get into the heats of vaporization and fusion and stuff like that. This is kind of sad and pathetic. These are Canadian troops in their armored car with Vickers machine guns in 1918. Yeah, the Canadian Army has never really been that well equipped, but the bulk of the war, everything was just being slapped together at the last minute. It was on a scale no one had ever seen before. So this is a little publicity photo showing them in their fancy armored cars. Oddly enough, there's a gentleman by the name of Ken Vickers, who was a sergeant at arms in Parliament, and he's killed a guy that was attacking Parliament with a rifle. And yeah, the sergeant of arms is really armed, but being a Canadian, his pistol was locked in a safe, and he still had time to go to a safe, unlock his pistol, dive through the hallway, and shoot the intruder. So I always thought it was kind of funny. Our country was protected by a guy named Ken Vickers just a couple of years ago. Next, we'll look into elastic weapons like the warbow or the longbow.